Section 5.4, Systems of Nonlinear Equations. This will be a short lesson, one learning target, solving a system of nonlinear equations. Nonlinear means we're dealing with functions and graphs that obviously are not linear, like we have a parabola here interacting with a linear function. In this case, there are 2 points of intersection, so there would be 2 solutions to this system of nonlinear equations. We also could look at having something where possibly we have a circle and a line, again providing 2 points of intersection, so there'd be 2 solutions there. Could have a case where we have a circle, and this is called a tangent line, a line that interacts or intersects with the circle one time on the outer edge, so we would have one solution there. It could also be possible to have, maybe we have a line that doesn't intersect the graph at all. In that case, there'd be no solution. We could also have a situation like this where we have a circle and a parabola with 4 points of intersection. So there's lots of different types of nonlinear systems of equations that we can see, and more options for different numbers of solutions. We're going to use the same 2 methods to solve systems of nonlinear equations, substitution method and elimination method. So we'll look at substitution method first. And apologize, I should be x squared plus y squared. So what we have here is the equation of a circle, and this is the equation of a line. So we could have this line passing through the circle twice, giving us 2 solutions. We could have this line touching the outer edge of this circle, giving us 1 solution, or it's possible that this line does not intersect with this circle at all, giving us no solution. So with the substitution method, what we're going to want to do is with this linear function here, solve for one of the variables. Now I would solve for y, getting y by itself because it has a coefficient of 1. So to do that, I would add y to the other side and subtract 10 over here, giving us y equals 3x minus 10. Now, if this y equals 3x minus 10, this y here also equals 3x minus 10. So we take this equation now and make the substitution. X squared plus, instead of y squared, it's 3x minus 10 squared equals 100. And then simplify. 3x minus 10 squared is 3x minus 10 multiplied by 3x minus 10. So that would be 9x squared minus 60x plus 100. And then combining some like terms, we have 10x squared minus 60x plus 100 equals 100. So what we have here is a quadratic equation that we could either solve by factoring or the quadratic formula. At any rate, it needs to be equal to 0. So if I subtract 100, so we can solve this quadratic equation by factoring out a common factor from these 2 terms, 10x squared and 60x. A common factor would be 10x, leaving x minus 6. So then the solutions will be x equals 0 and x equals 6. So what we have then are 2 points of intersection, but all we know are the x values of those points of intersection. What I mean by that is we have 1 point of intersection with an x value of 0 and another point of intersection with an x value of 6. What we don't know are the y values for those points of intersection. So we can go back to this equation where we had solved for y, 3x minus 10. So y equals 3x minus 10, and we substitute in now the x value that we have just solved for. So if x equals 0, then 3 times 0 here is 0. 0 minus 10 is negative 10. So then that point is 0, negative 10. Now if x equals 6, here 3 times 6 is 18. 18 minus 10 is 8. So y is equal to 8. Now we have both points of intersection. And anytime you're solving a system of equations, I've suggested this before, it's not a bad idea to check your work. So if we go back to the original system of equations here, let me go ahead and erase that. We have our two possible solutions of 0, negative 10 and 6, 8. If these are really solutions, then it should satisfy both equations. So 0, negative 10, 0 squared and negative 10 squared. 0 squared is 0, negative 10 squared is 100, 0 plus 100 is 100. 6 squared is 36, 8 squared is 64, 36 plus 64 is 100. So both of these points satisfy this equation. Now here, if x is 0 and y is negative 10, 3 times 0 is 0, 0 minus negative 10 is 10. And here, 3 times 6 is 18, and then 18 minus 8 is 10. So both points satisfy both equations, so they both are valid solutions. So that's the substitution method. And matter of fact, the substitution method is the only method that would have worked in this case. Reason being is oftentimes students will see, well, hey, there's a y and there's a y, and we have opposite coefficients, so we ought to just try to eliminate here like that. But the problem is, those are not like terms. This is y squared and this is y to the first power. They're not like terms, so these variables will never eliminate. Here we have an x squared and here we have an x to the first power, so these are not like terms. So these will never eliminate either, so it would have been impossible to solve this system of equations using elimination method. I've had students before try to square like this, but you can't just square individual terms like that. That's an invalid mathematical operation, so that doesn't work either. So the substitution method was the only method that would have worked there. Now here, with this example, you see that these variables are y to the first power, and these variables here are both x squared. So these are like terms and these are like terms. So it is going to be possible to use elimination method here if we can get opposite coefficients. For example, if we can get negative 15x squared here and positive 15x squared here, we could eliminate these variables. So if I multiplied, let's say I multiplied by 5, and here I multiplied by negative 3, what that would give me is 15x squared plus 10y equals 130. And then the second equation would be negative 15x squared minus 21y equals negative 9. Now we can do elimination method because we have opposite coefficients there. Those eliminate. This gives us negative 11y equals 121. So y equals negative 11. Now that we have our y value, we need to go back and find x. So we can take any one of these original equations. I'm going to use this bottom one here. So 5x squared plus 7. Now that we know y, we can make the substitution. 7 times negative 11 equals 3. And then add 77 to the other side. And divide by 5. And that's 16. And then if we square root both sides, we get x equals, don't forget the plus and minus, 4. So the situation we have here is we have two x values, positive 4 and negative 4, but both of them have the same y value of negative 11. And again, wouldn't be a bad idea to check answers. So if x is 4 and y is negative 11, we have 4 squared, which is 16. 16 times 3 is 48. And then 2 times negative 11 is negative 22. 48 minus 22 is 26. And then if we had plugged in a negative 4 there, we also would have had 48. So both points satisfy that top equation. Now the bottom equation, if x is 4 here, 4 squared is 16, and then 16 times 5, 16 times 5 is 80, 7 times negative 11 is negative 77, and that's equal to 3. And if we had plugged in a negative 4 right there, we would have also got 80. So it looks like both points satisfy both equations. Now, sometimes you'd be able to choose a method. It doesn't specify in the homework on some problems which method to use. It says choose an appropriate method. So for something like this, you would want to weigh your options and think here we have y to the first power, y to the first power. So these are like terms. So we could do elimination method and eliminate the y variable, or we could get x by itself here by moving 2y over and having it be x equals 2y minus 6, and then substitute that in to the x variable. So either method will work here, but I'm going to do substitution, or rather I'm going to do elimination method. I'm going to multiply this top equation by 2. And now that I have opposite coefficients there, those would cancel. You have to be a little careful here now because these are not like terms. 2x squared and x are not like terms. So when you add that column together, you get 2x squared plus x equals 10. So now we have a quadratic equation that we need to solve by getting one side equal to 0. And then we can try to solve by factoring, and if that doesn't work, we will use the quadratic formula. So 2 times negative 10 is negative 20. We need factors of negative 20 that add to 1. So that would be 5 and negative 4. So we can use the grouping method to factor this. If we group these first two terms here, the only common factor is x. That leaves 2x plus 5. If we group those two terms, a common factor would be negative 2, leaving 2x plus 5. And since both of those are exactly the same, that's one of the common factors we can factor out, leaving the x and a minus 2. So we have 2x plus 5 and x minus 2 as our two factors. So then x equals 2 and x equals negative 5/2. So we have x values for our two solutions, but we don't have y values. So if we take this bottom equation now, x minus 2y equals negative 6. We have, so x minus 2y equals negative 6. If we substitute our x values into that, so the first one would be negative 5/2 minus 2y equals negative 6. We can solve for y. So we'd have to add the 5/2 over. So negative 6 plus 5 halves. Negative 6 is the same as negative 12 halves plus 5 halves. That's negative 7 halves. So we have negative 2y equals negative 7 halves. If we divide by negative 2, dividing by negative 2 is the same as multiplying by negative 1/2. Then we have y is equal to 7/4. Now if we do the same thing but substitute an x value of 2 this time, now the equation becomes 2 minus 2y equals negative 6. Subtract 2 on both sides, and we have negative 2y equals negative 8. Divide by negative 2, and we have y equals 4. So it wouldn't be a bad idea to, again, check these answers. I'm going to use I'm going to check the answers here first. If x equals 2 and y equals 4, then we have 2 minus 8, which is negative 6. We also have negative 5 halves minus 2 times 7/4. So this would be 2 goes into 4 twice, so it's negative 5 halves minus 7 halves, which is negative 12 halves, which is negative 6. So both solutions satisfy the bottom equation. Now if we look at the top one, with x equals 2, here 2 squared is 4, 4 plus 4 is 8. Now for negative 5 halves, negative 5 halves squared is 25/4. Plus 7/4 is 32/4, which is 8. So we've checked both of them. And that's it for this lesson 5.4. Like I said, it's much shorter. Don't have to learn any new methods. It's the same two methods, substitution or elimination. I would recommend that you try to check your answers or check your solutions. Just make sure you have not made any arithmetic errors. But that should do it.